A shaft goes all the way through the earth. So let's say we have a shaft here which goes all the way through the earth. Find the equation of motion of a body falling into the shaft. So when body is dropped from here, what should be the equation of motion? How long does it take the body to reach the other end? And what is the velocity of the body at the Earth's center? So we need to know first what will be the force on this particle while it is falling down the shaft. So let's say it is at a distance x from the center of the Earth. So we know from the chapter of gravitation that gx at the distance x is given by gmx by r cube. So the force on the particle is of course mgx. So at a distance x, the force on the particle is mgx, that is gmm by r cube times x. So gm by r square we can write as g, so this simplifies to mg by r times x. So we can see that the force towards the center of the earth, that is proportional to the distance of the object from the earth. So that is our condition for SHM. So the particle which is dropped in the shaft will be performing SHM. So our standard equation for motion for SHM will be A cos omega t. Cos omega t because starting from the end. So in this equation, A is amplitude is radius of the earth. Omega is root k by m. K will be mg by r. So this becomes root g by r. So our equation of motion is r cos root g by r t. Now velocity at the center of the earth. So that in SHM we know the maximum velocity is omega a. So omega is again root g by r and amplitude is r. So this gives v naught is equal to root gr. Now time period for the whole SHM is 2 pi by omega. So that is 2 pi root r by g. So these are our answers. All right.